Bismillahirrahmanirrahim. Assalamu alaikum. Good evening. Hello everyone. I wish all of you a good health. Previously, we have already talked about the organic compounds and its properties. Especially, we talk about the carbon skeleton. We also mention it that carbon have a unique ability to form a strong covalent bonds. Okay. Additionally, we studied that carbon have some unique properties like catenation, and we already study about their tetravalency. So today I am going to talk about further and detail. So several million organic compounds known today, and thousands of organic compounds are prepared every year. So, a detailed study of carbon shows that carbon is an element, but still its compounds are in millions. Therefore, it is defined as hydrocarbon and their derivatives. So, today we will talk about the hydrocarbons and specifically its derivatives, which are derived from hydrocarbons. But before I go there and start my topic on hydrocarbons and its derivatives, so before it, I want to discuss the organic compounds and its sources. Broadly, we categorize organic compounds into two types: those compounds which are occurring naturally, which are present in our nature, are formed by the nature. Okay, so naturally occurring organic compounds are what? Coil means coila. Okay, natural gas, crude oil, food, etc. And synthetically means that man-made, that we prepare it for our own benefit. Man-made organic compounds are called synthetic organic compounds like plastic, detergents, medicine, etc. Simplest organic compounds. It is composed entirely of carbon and hydrogen atoms and are widely used as a fuels. Okay, only hydrocarbons are entirely composed of carbon and hydrogen atoms. Okay, and are widely used as fuels in our cars and various automobile industry. A part of it like diesel, gasoline, natural gas, and LPG, liquefied petroleum gas, are common examples of hydrocarbons. What I have mentioned? I mentioned that diesel, gasoline, natural gas, and LPG Liquefied petroleum, gas are common examples of hydrocarbons. Uh, these hydrocarbons, as they contain only carbon and hydrogen atoms, therefore, hydrocarbons are non-polar covalently bonded compounds. Okay? Scientists classify hydrocarbons as saturated and unsaturated hydrocarbons. Saturated hydrocarbons are called alkanes, and unsaturated hydrocarbons are called alkenes and alkynes. Okay, 1 is 2, 2 is 2, 2p, 2. It means carbon atom has 2 electron in first shell of 1s2 orbital. Then in second shell there are two orbitals, s orbital and p orbital. Okay, so the remaining four electrons are present in its outermost shell. Okay, so the maximum capacity of carbon atom, it must get 4 electrons in its outermost shell to get stable. So what happens here? One hydrogen atom bonded here, okay, and another hydrogen atom is bonded here, sharing their only electron, and one hydrogen atom, another hydrogen atom sharing its only electron. It is the formula of CH4. Okay, we call it first member of hydrocarbons, especially of alkane series. Okay, methane, commonly known as marsh gas. Marsh gas. We are familiar with marsh gas because we all know that produced by the cows dung, the pungent gas. Let's take two carbon atoms. Suppose this carbon bonded with three hydrogen atoms, and this electron it share with another carbon atom. Okay, so it is the second member of the alkane series called ethane, C2H6. Look what happens here. This carbon atom, its share its 4 electrons, 3 of the electrons with hydrogen atoms, and one, the remaining 1 electron is shared with another carbon atom. Okay, so this carbon also reached to stability, and it also reached to stability both of the carbon atoms are using their four electrons in the bond formation. Okay, and these bonds are covalent bonds. Okay, and both of the carbon atom shows tetravalency. Bonds are forming, both are forming four covalent bonds. See here, this bond, this bond, this one, and this one. One, two, three, four. Look at two, the second carbon atom. It also shows tetravalency. One, two, three, four. This bond is common to both of the carbon atoms. So, and also it shows a catenation. Look, this carbon is linked to this carbon. So both the properties are showed here in this diagram. Three carbon atoms. It is the third member of the alkane series. Methane. This one is ethane. The third one is propane. Okay, from 1 to 10. It makes a longer chains of straight hydrocarbons. Look, they are linking with each other in this fashion, and long chains are formed. Propane 1, 2, 3, 4, butane 4 carbons. Now count the hydrogen atom 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. Okay. Let's take 5 carbon atoms. 1, 2, 3, 4, 5. Make it quick. These are hydrogen atoms. 5 means penta. Pentane. C5H12. Let's draw hexane. 1, 2, 3, 4, 5, 6. Hexane. Count 1, C6, H14. Heptane. C7, H16, C8, H18, card, octane, nonane, C9, H20 are forming in this fashion, having long chains. Okay, we had already studied that organic compounds are complex compounds. Okay, so this is a decane, C10, H22. All understand the basic essence of organic chemistry. In this lecture, we had studied and understand why carbon atom is the element of life. Okay, then and also explore the real world applications, and finally touch upon why they are so crucial to our existence. Okay, we have already studied the unique atom and why it is a carbon atom, because carbon can show tetravalency. It can form four bonds in hydrocarbons. Okay, plus we have already studied that these carbon show catenation, means it can link with each other, okay, in a long manner, in a long fashion, okay. And we had already studied that these carbon atoms have the ability to form single bonds plus double bonds and triple bonds, okay. We will study it.